Okay, good morning, everyone. Sorry for the holdup. We're having some technical difficulties, but we're all ready to go now. Welcome to the latest ATS Traffic webinar, Smart Work Zone Solutions. We're going to get started here right away, but before I do, I just have some quick housekeeping items. If you have any questions throughout the presentation, feel free to send them our way using the question tab on your control panel. You should see the controls on the top right of your screen, and you might have to expand it in order to see the questions in the chat box. We'll get to as many questions as we can following the presentation, and if we can't get to all of them today, we'll make sure to follow up with you. We'll also be sharing the recording of this webinar, so keep an eye out for that in your inbox. Now I'm going to turn it over to our presenter today, Wade Robichaud. Wade, take it away.
Okay, good morning, everyone. I apologize for the technical problems we've been experiencing here this morning, but we will get this show on the road now that we're all very familiar with this one slide that we've been parked on for a few minutes. So I'll just quickly explain this, and then we'll kind of get, jump right in with 2 feet, so to speak. So 54 years experience, 15,000 plus products, 1,000 signs manufactured a day, 250 plus staff across Canada, and about 37 salespeople. ATS Traffic, one-stop shop for all things traffic safety. We're headquartered at Edmonton, actively pursuing, work in Ontario, Eastern Canada, just trying to expand our service and product depth across the provinces there. But what we're here to learn about today is smart work zones and how we can implement smart work zone technologies. So out in the public, I guess, so to speak. So on a construction project, on a potentially a flood detection system. Smart work zones, in the simplest ways of explaining it, is really site-specific ITS style-driven technologies. So we've got everyone's got cell phones, everyone's got cars that are potentially connected with 4G LTE modems. Utilizing all of this technology and banding it all together helps us increase the safety of the workers in the work environment. It also provides real-time information to the motorists and the project team as they continue down, ensuring that it's safe to have people out on the road. So the way that we kind of use this is Vermax powering a system called JAMLOGIC. And what does that do? Well, JAMLOGIC essentially takes raw data. So it's taking information from cameras, it's taking information from speed sensors, weather stations, microwave sensors, Bluetooth from your vehicles, your cell phones, and even network data. It's driving it all up into the cloud, and using some algorithms, it is spitting out real-time information. And we're giving that information to the downstream drivers, or the traveling public, or even the walking public. And we're feeding that information via DMS, or dynamic message signs, portable trailers, portable speed or dynamic speed displays. And we can even take it one step further and drive information to public websites like a 511 or even email and text alerts. So a work zone crash occurs, from statistical data gathered from the U.S. Department of Transportation. Between 2008 and 2015, a work zone crash actually occurred every 5.4 minutes. So in a work zone, 70% of those crashes resulted in a major injury. So we want to take this same technology, we want to take what's out there right now and make work zones safer. And the way we do that is by using Vermax, JAMLOGIC, and smart work zone technology. So for those who don't know what or familiar, I should say, with Vermac, they are a manufacturer, leading manufacturer, global manufacturer of portable changeable message signs, LED enhanced signs, radar signs, arrow boards, specific to work zones, but also non-specific to work zones as well, as we'll find out later in the presentation, where we've taken these devices and applied them to other styles of ITS. So we'll do a very quick equipment overview, and just kind of just jump into, again, the presentation. So we won't spend a ton of time talking specifically about the boards. More or less want to bring your attention to the styles of boards and styles of products that we can use to implement what we would call a smart work zone or an ITS solution. So right here we see that Vermac, several different sizes of message boards. We've got a large size, we've got a 3-line message board, 8 characters across, and then we've got these full matrix ones as well, the 320s. We've got 3812 Pro Series, we've got 548 Pro Series, 4880 Pro Series, sort of metro medium style boards for urban environments. We've got aero boards that are smart capable. And what we mean by smart capable is the ability to add modems to aero boards that allow them to feed data directly into JAMLOGIC that allows you to see the beginning and the end of the lane closure. And you can also see if they're on, if the work zone is active, and if they're off, you can also determine that the work zone is now closed for the day. Vermac also has several other camera and sensor trailers available to the market that are easily implemented into a smart work zone. Some of these are the CT2430, which you see off to the left-hand side of your screen. In the center there, you see basically a snapshot of a live view of what you would see real time if you were to deploy cameras in a smart work zone. And then off to the right-hand side of the screen, you see sort of a microwave sensor trailer, and that could have a Wavetronics or any other sort of radar or microwave sensor on there to collect data. And then we want to talk about the SpeedMac VP. So the SpeedMac VP actually is something really unique, specifically designed by Vermac for implementation in smart work zones. And this is actually one of the bigger data drivers behind why how and why smart work zones function. So SpeedMac's, Vermac SpeedMac VP is basically a combined design with a vertical solar panel so that it's constantly being charged and constantly active. It can be easily set up by one person, operate all season long without having to recharge, and it's actually the only autonomous NCHRP 350 tested and approved device on the market for this type of implementation. A little bit more about the SpeedMac is there's an integrated radar, a 4G modem with GPS capabilities. It's a lithium battery with solar regulated package on there as well. You can take this barricade light, or what looks like a barricade light, attach it to any battery or solar powered traffic control device, allocates, auto locates with other SpeedMacs out on the road, so you can have multiple devices staggered across a road surface or a construction site. That also helps you sort of drive data into JAMLOGIC, which we'll get to in a couple of slides further. The general specifications around how we want to, lay down data or deploy devices, every 100 to 500 feet to capture the best data possible. And that's capturing either Bluetooth data and or capturing radar and speed data through the construction zone as well, leading up to and exiting. But what we really want to talk about is the JAMLOGIC software and how these devices that we just saw previous slides, how that all feeds into JAMLOGIC. And really JAMLOGIC is the driving force. It's the brain, so to speak, behind what a smart work zone is. So JAMLOGIC, fleet management software, you can remotely monitor, maintain, and manage your entire fleet. So as you can see there off to kind of the right-hand side of the screen, you see computer there, that's sort of giving you a dashboard. Let's say you have 100 assets all loaded in there. Well, you can manage them all from one very central place. Your radar trailers, your speed trailers, your dynamic speed signs, your message boards, your camera trailers, all of those are all managed directly from JAMLOGIC. So really at a fingertips notice, you can make any changes you want. It is also available on mobile and tablet. As long as you have access to the internet, you can log in and access JAMLOGIC essentially anywhere in the world. It gives you interactive list and map views like we were talking earlier. This is a kind of a snapshot of a project or a smart work zone sort of style implementation that we did here in Edmonton. These cameras are located on the white mud, and you can kind of see here, they are dirty. This was kind of a snapshot taken in the winter time there, but for presentation purposes, it just shows how you can implement cameras, permanent or mobile, like we just looked at a few slides earlier. It does give you some message sign history. So if you're changing messages on the fly and there's different types of work happening, and or let's take it a different step, if there happens to be an incident on the road, going back and looking at all of the messages that have been displayed, you can actually see, when it was displayed, who changed it, if it was a user event, if it was a scheduled event, or if it was an on-site change. It will all drive all that information back into JAMLOGIC and categorize that. You can go back several years worth of data. You can go back several minutes worth of data. It is very open-ended and very intuitive to use. Some more additional kind of information on the AXIS PTZ cameras. The information here, again, is real-time information on what is happening on the roadway. So we've taken a snapshot of what it looks like in the dashboard, and now we're looking at what you're getting live view out there kind of in public. So this was, I think, sometime in early January. There was a snowstorm, there was an incident, and we were able to log in and assist EPCOR with kind of determining, where that incident happened on this road surface just on the White Mud Drive. So again, using cameras in combination with message boards, with error boards and trailers just adds another level of engagement and visibility into how well or potentially on the negative side of how poorly the work zone is working, and that allows you to make changes and understand the changes that need to take place. Here's a quick shot of JAMLOGIC Mobile. Again, this is on iPhone, but it also works on Samsung devices or any Windows devices. As long as it's internet capable, you can log into JAMLOGIC Mobile version and also kind of manage and view cameras and change messages on the fly. So should you be a supervisor on site trying to manage a large work zone project, well, instead of getting out of your vehicle, you could sit in your vehicle, manage the messages, manage the cameras, and understand the traffic flow, the traffic flow that's happening while you're idle, kind of on the side of the road, without having to be in a dangerous situation by getting out of your vehicle. So we want to talk about smart applications. So we've talked a little bit about the JAMLOGIC platform, which is the kind of the brain, the guts, the driver behind what Smart Work Zone is or what ITS is. But how do we apply that? How do we apply message boards, error boards, radar trailers, dynamic message signs, even traffic lights for that matter? How do we apply those in a smart application? So we do that by at the very beginning stages of the design phase. So we're designing in at the very beginning of the project, even before ground has been broken. In the engineering phase, how can we make a work zone smarter and safer? So we look at the scope of the project. We sit down with our internal engineers with Untitled Traffic here, which is an internal ITS kind of driven department. We sit with our traffic engineers as well that do our CAD drawings. And we look at how many signs are going to be there. We're going to look at if there's a necessity for traffic lights. We're going to look at if there's a necessity for dynamic speed signs. So if we want to, say, enforce a very specific speed at 8 o'clock through to 10 o'clock in the morning, or 8 o'clock till noon, but at noon or 1 o'clock the speed then can change because the work scope has changed. We can maybe bring the speed back up. Vice versa, if the work scope is going to increase noon to 5 o'clock, we can also drive that speed down. So that gives us an allowance to put in some dynamic speed signs, so we can have your standard posted speed limit, your reduced speed limit, or back to increased speed limit near the end of the day. Or if the allowance is that if there's no work, you go back to regular speed, then we could actually have that dynamic speed sign turned back to the regulated posted speed limit in that work zone. Another really cool feature is this truck conflict application. We've actually done a few of these in the past, some of them up in Fort McMurray or up in the mine sites up in northern Alberta. The challenges that we were experiencing up there was we had large mining vehicles crossing a major thoroughfare. But that wasn't really the issue of the vehicle crossing the thoroughfare. The issue was having flaggers on site at a high-profile location, at a heavily trafficked location, and the challenge was, let's take that flag person off the road and let's replace it with technology that makes it a lot more safe for the motoring public and for the construction agency in terms of risk avertment from having a person on site in close proximity to high density traffic and also close proximity to heavy construction equipment. The idea behind this is that we've got sensor trailers on the opposite sides of the main thoroughfare where we're trying to have trucks either enter or cross directly. Large vehicle approaches the sensor. Again, this is set away from the road, from the main roadway. It triggers an activation on the sensor trailer. That then sends a signal to, say, a portable message sign, or even an optional, flashing beacon trailer that we can put downstream, say a couple hundred meters, to let people know that are, upcoming. If there's multiple vehicles or multiple tractors or construction equipment crossing the roadway, it just alerts them and lets them know that there are trucks entering the highway. Or, again, we don't have to have trucks entering highway. We can have construction equipment crossing highway when lights are flashing. So it's all scalable and adjustable and customizable to your unique situation. But these are applications that are ready to mobilize and deploy now that helps take some of that risk away from the people that we have standing on the road, turning the stop slow paddle. Take those people out of a dangerous situation, replace them with technology, and then the byproduct of that is we're also educating and informing downstream traffic and the motorists that there are going to be some delays. So prepping them in advance of where the congestion might be just helps ease their kind of maybe potential frustrations or their anxiety about being in congested traffic or even traveling close or near to heavy construction equipment. So we talk about like automated queue warnings as well. So that's truck conflict applications. So we've talked about taking these technologies and assigning them to, say, construction sites or conflict areas where we're moving heavy equipment. But now let's take a look at what happens if that construction equipment or the movement of equipment is tying up traffic, is congesting traffic, and it's an automated queue warning system that we want to implement. So what is an automated queue warning system? So automated queue warning systems are really based on real-time traffic data. Queue detection and warning systems automatically inform travelers of the presence of what we want to call downstream stop and go traffic with the use of like message signs positioned upstream, as well as radar sensors that are also helping drive the message signs upstream. The benefit is that the motorists can anticipate the upcoming situation, and the end result of informing the motorist downstream or upstream is we're going to reduce rear-end collisions. We're going to successfully sort of engage with traffic and help get their anxiety brought down by having them start to slow down well in advance of potentially what would be up ahead. So we look at the graphic on the screen and we say work zone area. Sensors on sensor trailers, could be on an aero board, on a traffic control device. The important piece of information that we want to talk about is, yes, SpeedMac VPs and the SpeedMac systems are sensors, but it doesn't mean that the message board that you own can't have a radar gun and a sensor added to it. It doesn't mean that we can't have an aero board have a sensor added to it. So when we say multiple devices may be deployed based on the project requirement, it may not necessarily mean multiple SpeedMacs. It would just necessarily mean multiple products. So one message board, one radar board, one aero board, and maybe in combination with one extra SpeedMac to drive that data. And what that's doing is, as the traffic is passing all of these sensors, it's collecting data. It's determining if car A took 10 minutes to get to that next sensor, car B took 15 minutes to get to that next sensor, and then car C took 20 minutes to get to that sensor. Well, there's clearly some situations there of congested traffic. So what it's going to do is it's going to start determining speed levels. And if it's detecting speeds between sensors are reaching a certain limit or cutoff, it's going to start automatically changing the messages downstream to the public that are traveling there, giving them indications of what to be prepared for. So whether stopped, slow, or free flow traffic. So if there's no congestion and everyone's driving to the speed limit and no one's acting crazy in the roadway, then the message boards will actually stay static and just say road work ahead, lane closed ahead, merge over, zipper merge. I mean, there's lots of different varying messages that we can put on the message boards for these types of programs or products. But again, the concept here is automated queue warnings. We're using sensors, we're using message boards, we're feeding information downstream to the drivers, and that should help reduce the rear end collisions like we were talking about in the slide earlier. There's 70% of those are severe injuries. If we can help reduce that, there's data that shows that having an automated queue warning system helps affect change and can help reduce maybe up to 70% of those serious or non-serious rear end collisions. So then taking automated queue detection and automated queue warning and applying that now to travel time and alternate routes. So using all of these three pieces in combination, we're letting people know that there's congestion, we're letting people know that there's stopped traffic. Now let's see if we can take some of that congestion and move it off into side streets or other collector roads or arterial roads. Travel time and alternate route applications are continuously updated automatically to provide current real-time or length of delay time between the driver's location and a specific destination downstream. So the concept there is the benefit is the motoring public is informed and can make alternate route decisions on demand. So if I'm approaching a congested area of traffic, I know I've already entered a work zone. I've been prepped that there might be stopped or slow traffic ahead. If the very next message board that I see as I'm traveling towards the work zone, already in the taper or already traveling in reduced lanes, if there's a message board that pops up to me and says, consider alternate route or alternate route next exit, that might prompt me to make that decision. And there's, depending on the situation, depending on the project, depending on how many arterial roads or if there's one ways or not one ways, we could have varying levels of alternate route. So we could have one right away at the beginning of the work zone. We could have, potentially there's an option to have one midway through the work zone. That's going to help ease up that congestion in the work zone so that the construction traffic can get to where they need to quicker. The workers feel a lot more safe. They don't have to be worried about getting, potentially hit by oncoming vehicles. So the main idea is, it also helps prevent unexpected backups, right? So the potential rear end collisions, like we were talking about before, we also want to try and reduce those too. So we're reducing rear end collisions because of automated queue warning. We're reducing rear end collisions because we're suggesting alternate routes. The travel time piece as well. So with sensors located along the corridor, the work zone corridor, it's tracking, just like automated queue warning, it's tracking travel time and distance, but now we're actually projecting that on the message board saying X time to X location. So if that's 91st Street to blah, blah, blah Street, we say 10 minutes. And that will change dynamically as traffic continues to either get congested or as traffic eases up, those times will change up and down. And eventually, if we get to free flow traffic, then there may not be a time displayed, or there may be very, a baseline time set, saying 5 minutes to the next street or past the work zone there. So there's a couple of ways that we've, ATS Traffic has actually implemented and utilized these smart work zone technologies. These technologies have come in handy on very specific projects. And again, they're fully scalable and they can apply to almost any project. It's really just dependent on how much data, how accurate the data the contractor, the construction company wants, or the federal agency that wants to have a safer, smarter work zone. We can apply all of those and help increase what we call construction or production, and try and get the projects completed faster. One of the ways that we did this was with the Iverstrong Bridge, which is a bridge project that was in Calgary, and it was an enhanced work zone management system to kind of make their life a little easier to get their project done. This is a little snapshot of what the project plan looked like prior to implementing it. So we did some virtual mock-ups. You can see through the virtual mock-up pictures here along the top and the bottom of the slide. We just kind of dropped in some message boards and some ideas of how we could make this thing work, and pitched this to the contractor. Contractor approved it based on the fact that we could help them complete the project on time. So we talk about the challenges. The challenges were environmental. There's a minimum ambient temperature range. There's a timeline to complete this project prior to the Stampede. What is the Calgary Stampede? We all know is the greatest outdoor show on earth. What that does is drive traffic. It drives attendance, and that's going to plug up the roadways that are all inbound towards Stampede Park or wherever the event was taking place. We wanted to try and minimize the inconvenience to the motorists and maximize the safety for the motorists and maximize the safety for the construction workers on the project. The other challenge that we were presented with is this project already had an accelerated construction period and an increased volume due to lane and speed restrictions based on what was feeding onto the Iverstrong Bridge. So what was the solution? How did we apply everything we learned earlier in the presentation to now? That solution was smart work zone components, sensors, software, messaging. We used automated queue warning systems. We implemented alternate route systems. We had an implementation of permanent dynamic message signs. So versus having trailer mounted signs, we actually implemented permanent message signs. The byproduct is we're slowing traffic. We stopped the queue messages. We had radar sensors placed upstream that was driving information to JAMLOGIC in both northbound and southbound locations. But the idea is that we're driving this information to JAMLOGIC. It's making calculations autonomously without human input, driving that information back down to the message boards, allowing the motorists on the roadway that there is going to be travel time to Stony Trail 26 minutes. They can make those alternate route determinations on their own as they approach an area to make that alternate route choice. Sorry, skipped ahead a slide there. I apologize for that. This project was quite unique. We did end up having them complete work ahead of schedule. It was a fairly unique project in terms of implementing the right solution. The City of Calgary definitely wanted to make sure that we were implementing something that was autonomous, that had limited bodies on the roadway, and they also wanted to make sure that the impact to the construction site was minimal. So less potential for crashes, less potential for incidents, and helping divert traffic onto different roads or onto arterial roads away from the main construction project allowed them to have more equipment on site and get their construction rehabilitation on the bridge done in an accelerated fashion. So we talk about these solutions when implemented on a construction project or a bridge rehabilitation project or a truck conflict application. All of those applications that we've talked about thus far are all in what we would call, work zone applications. But it's not to say that JAMLOGIC and smart work zone technology / ITS solutions can't be permanent as well. So were approached by EPCOR, and we were approached by the City of Edmonton, actually, I think approached EPCOR, and EPCOR Water approached us for a solution to a challenge that they had, and the challenge was every once in a while, the white mud in Edmonton, if you're from Edmonton, you're aware of this, every once in a while, the white mud seems to flood, and those very specific locations are noted on a map here that we'll show in a few slides. But the idea that we're trying to depict is, like we were saying before, the principles are all the same. So what we've talked about on truck conflicts and work zones and those types of implementations, the principles are all the same. Provide real-time information to motorists at key decision points, help increase safety and mobility. Those principles are shared whether it's a permanent installation or whether it's a non-permanent or mobile or work zone specific installation. Providing real-time information is the key to all of these smart work zone concepts. So, recent extreme weather events in Alberta, buildings, roads, bridges, pipelines, generally sensitive to gradual changes in temperature precipitation patterns. What can that cause? It can cause water mains to break. It can cause potential flare-ups based on how dry the undergrowth is in forests. So we've experienced severe weather events, severe hail events, severe flooding, and severe fire. All of these can overwhelm the capacity of the infrastructure very quickly. So having permanently installed ITS or smart work zone style solutions can help when there is an emergency, to help divert traffic away from areas that we don't want people going towards. We don't want you going towards the flooded underpass. We don't want you going towards the flooded downtown core of Calgary proper. We don't want you heading towards the extreme fires that were happening in Fort McMurray and a few years earlier in Slave Lake area. There are major financial impacts as well to consider when these types of events happen, and the cost of these implementations from a smart work zone perspective are very small when compared to the billions of dollars or millions of dollars that are required to get things back in order. So having these things kind of deployed in advance or looked at as a permanent, full-time, long-term solution to migrating or mitigating risk, managing traffic, moving people better, it's always good to look at what the financial impact of a major sort of weather event or natural disaster to see what we could do. So the challenge that EPCOR presented us with is, since the year 2000, white mud kept flooding. Became severely flooded in multiple storms, multiple hail events. The drainage specialists in the city of Edmonton even openly acknowledge that that there is a major challenge there, and when these aggressive events happen, they will overload the services. So it's going to overload drainage. It's going to overload the pump stations. So we needed to come up with a way to divert traffic off of the white mud in a short amount of time when these weather events come in. So these underpasses flood within minutes, not over several hours. So that's how quickly we needed to change the traffic flow on the white mud. So the way that we did that was we utilized portable message boards, because this is a scenario that seems to exist sort of in the spring, early spring, throughout the summer, not so much in the fall. So we're using portable message boards. We're utilizing a JAMLOGIC server installation. We're using ultrasonic sensors on the underside of the bridge. We're using capacitance contactless sensors that are either sunken into the drain or actually attached just adjacent to the drain. We're driving information through into the pump house, and then we have our cameras that are attached to the side of the pump house, all driving a flood detection customized solution for the city of Edmonton and EPCOR. The grand scale of how this works is a flood event happens, the sensors trigger JAMLOGIC to send information to the message boards. The message boards start lighting up saying underpass flooded, alternate route ahead, or must exit at. In this case, we have must exit at 91st Street because everything past there is sort of a no-go. Once you get past there, there really is no turning back. You're sort of stuck on the white mud basically until the water subsides and you can travel under the underpass freely. All of this information transfer happens within 30 seconds to a minute. So the sensors are triggered. There's a slight delay. It goes up to JAMLOGIC. JAMLOGIC sends information to the message boards. At the same time that's happening, it's sending email and text alerts to emergency services. It's sending email and text alerts to EPCOR so they can deploy people. They can, I think even alerts go to the City of Edmonton directly so that they understand what the impact is on the white mud. All of that information is transmitted to the people that need it almost instantaneously. So event, alert, event, alert, and it's that quick. And that's why the use of Vermac's open-ended architecture allowed us to do this very customized, scalable solution. The interesting idea behind this is that now that we've implemented this, it's only just bolt on more pieces to have a fully implemented and managed an autonomous system, flood detection autonomous system along the white mud that doesn't really require someone to sit there and manage the boards. It kind of turns on by itself, and when the water subsides, the system actually turns off by itself too. So the message boards go back to blank. There's no more emergency. Additional email alerts are sent out, letting people know that there is no more flood event, or that the water has subsided to the point where traffic can free flow through under the underpass. Again, this is all in conjunction with emergency services, so fire and police, who will be also deployed at the same time. They're also getting messages because we want to also stop traffic from going any further. Deal with the traffic that didn't get the message on time, deal with the limited amounts of potential flooded vehicles or underwater vehicles that got trapped in the underpass, kind of severe flooding, stack up the cars behind the road closure, get them off on an alternate route, ease the congestion, and then slowly open the road back up. Messages start going off, and then the road is back to free flow. Again, this isn't something that, the water subsiding isn't happening within minutes of it going off either. So understand that, the idea is we're getting the right people on scene as fast as possible to manage that situation, that risk. And then once the people are on site, they're managing that very specifically, very locally, but the message boards are still on downstream, helping people get off the white mud, get off as soon as you can so that we're not getting stuck in congested traffic. And as we're coming close to the end of our presentation here today, I really appreciate everyone's again time investment, sticking with us all the way through our technical issues at the very beginning. The last thing that we want to mention here is utilizing Vermac, utilizing JAMLOGIC products, utilizing these for COVID-19 messaging. We all know what is happening out there right now, and being able to get out there and utilize these boards, thank the healthcare workers, inform the public of social and physical distancing measures that are required to help us combat this pandemic. This is just a shot of a message board here from Regina General Hospital. We did donate several boards out across Canada and the Western provinces to many major kind of health units there. Alberta Health Services, we've donated several boards to them. We've donated some boards to some other areas across the provinces as well, like Regina General Hospital, some places in Winnipeg, in and around there. Even in BC, we did donate some boards. So the idea here is JAMLOGIC and Smart Work Zone technologies all feed into the same place. Now you can actually deploy boards, and by physical distancing and social distancing, drop the board, go back to your vehicle, change the messaging, and you're still respecting what the health agencies around the world are asking us to do, is stand together by standing 2 meters apart. I thank you very much for your time today. I do have 10 minutes left and aside for questions, and I'm happy to take and field any questions that you may have from this presentation.
Okay, does anybody have any questions for us? So far, I don't see any popping up, but let us know. We'll give you a minute. Anything else you wanted to touch on, Wade, or?
Thanks, Efton. Sorry, there's a bit of a delay there. Yeah, there's lots of. I'm sure there's a lot of information, and it's very specific on how we can implement these types of solutions and devices. The idea here is that we want to get people thinking and talking about how can these apply to my scenario, or how can this apply to my specific problem or specific work zone. And the idea is it isn't just one overall solution. Each smart work zone implementation is very specific to the challenge that you're trying to solve. And via this presentation today, it's more of an understanding and showing that there are solutions out there for you. We can help you mitigate those risks on site at your construction project. It's just a matter of knowing what's available, how to implement it, and then partnering with companies like Vermac and ATS to help you implement and drive success on your project.
All right, we do have one question. For the cameras, how do you deal with bandwidth and using data not to have large bills?
So the idea behind the cameras is the bandwidth is driven by 4G LTE modems. So the cameras that are deployed on work sites, they have their own 4G modem. Those modems are requiring a SIM card. Clearly, the end user supplies the SIM card to those modems. Now, if it was a managed work zone, say from an ATS perspective, then that's all bundled into the cost of, say, running your smart work zone implementation for the project. But the way we handle bandwidth and avoiding large data charges is the cameras aren't specifically designed to be monitored 24 hours a day, 7 days a week. The concepts behind that are JAMLOGIC allows you to log in, find the cameras on the dashboard, view the cameras, do what you need to do, pan, tilt, zoom, focus in on one very specific area. There's a wreck ahead. You've got a camera deployed in your work zone. You can see the wreck, you can understand what's going on, you can see emergency services over there, and then you log out of the cameras. While you're logged into the cameras, though, you can quickly override messages. So say emergency services maybe haven't been on site yet. Well, you're using the camera for a very short period of time. You're looking at the message boards that are on site. You identify those assets in JAMLOGIC on the dashboard and quickly override the messages saying emergency services are en route, just as an awareness to them, but you're not constantly watching the cameras. Again, the cameras are more of a bonus add-on to the work zone project to allow you to see current work, how much work has progressed. I mean, it's not really to be Big Brother, but at the same time, there's some folks out there that may want to see that visual. Maybe there's contractors that have a stipulation, they want to see a visual component to it. Well, having cameras on the site allows that visual component to be satisfied on that request. And outside of that, though, again, the bandwidth question, cameras aren't designed necessarily to be viewed all the time, 24 hours a day, 7 days a week. There are small bandwidth packages. There are some H.264 kind of protocols built in as well, so it helps compress the data so that it's also not sending like gigs of data and throttling your cell phone plan either. So small data packets, sending small data information, you're logging into the cameras, you're viewing them for short periods of time or to just or quickly audit the situation or audit the work zone, and then you're logging out. So you can sort of self-moderate and self-manage your bills as well. And if you're finding that there's a lot of data coming through, then it's just about adjusting how you're viewing the cameras and viewing those live feeds.
Okay, so we have a couple more questions here. Question about the stats at the beginning of the PowerPoint. Were they national stats or?
I'm sorry, Afton, you said the stats at the beginning of the PowerPoint?
Yeah, someone is wondering if they're national stats or for...
Those stats are, they're American stats. They were from the FHWA from 2008 through to about 2015.
Okay. And we have a couple more questions here. Do the cameras have an onboard hard drive system or an SD card to record?
So the cameras by nature are designed to be more live feed. Vermac does have camera systems, site surveillance and sort of security trailers that do have onboard capabilities of recording data, but there is also a component of those trailers also feed, capture, and record and drive data and store it in the cloud as well, so that there isn't potentially an onboard situation where the hard drive potentially fails, the camera trailer, knock on wood, somehow gets, not knock on wood, but somehow gets stolen or something happens to it and the hard drive is missing or gets lost in the truck or lost on the way back to the facility. There are capabilities of recording data locally, but the ideas behind the camera trailers that Vermac has is live feeds and then drive data to the cloud and store activity data and even image captures and store that all in the cloud so that it's more to fingertips ability or availability. So you just log in, you grab your data, and then you log out and you get what you need without having to have a potentially a hard drive on site that may fail or potentially get lost.
Awesome. That is all the questions we have, and we'll be sending out the recording of the webinar as well as Wade's contact info. Thank you all for joining us. I encourage you to reach out if you have any other questions about the topics we covered today, or if you'd like to learn more about how smart work zones and ATS Traffic can help with your traffic accommodation strategies. So with that, thank you so much, Wade, and for his insights today, and thank you all for joining us and for your patience. We'll see you next time.